We have a differential equation here to solve. dy by dx plus 3y equals 15. I'll give you a hint that you should use the integrating factor. In fact, if you tried, you wouldn't be able to use separating the variables. Direct integration, you wouldn't be able to use that. Alright? So, pause the video. Go ahead and solve this equation. Okay, you finished? What did you get for it? Let's work it out. Now, you will see that this equation is in the form dy by dx plus py equals q. And when you can get it in this form, then you use the integrating factor. P and Q are either constants or functions. Now, here, you can see what P is. P is equal to 3. Of course, Q is 15, but P is the one you're interested in. You must now write it in the form of the integrating factor. Let me just put IF for the integrating factor. Now, the integrating factor is equal to e to the integral of p dx, which in this case is e to the integral of 3 dx. Integral of 3 with respect to x. Now, you must remember the next step, multiply by the integrating factor. Alright, that's the next step. So you have dy by dx, dy by dx multiplied by e. By the way, let's find the integral of 3 dx. So this is equal to e to the, when you integrate 3 with respect to x, you get 3x. So it's 3x. We will leave out the constant of integration here. So this is e to the 3x plus, what was it here again? 3y equals 15. So we have 3y multiplied by e to the 3x equals 15 multiplied by e to the 3x. Alright? Now, over here is going to be in the form of the result of finding or of differentiating a product. This comes from product rule. And remember what the product rule says. You have the product of two functions. One of them is u and the other one is v. You multiply these. Now, the derivative with respect to x of uv equal u dv by dx, u times dv by dx plus v times du by dx. Remember that. So you have two functions multiplied. You differentiate that product. You hold one as it is. Don't change it. Multiply by. Differentiate the other. So let's consider u as the first and v the second. You hold the first times. Differentiate the second plus. You hold the second time. Differentiate the first. That's the product rule. Now, what could possibly have been the product here? Now you will see that what happened here is y is differentiated with respect to x. So what you do is have dy by dx, and you hold e to the 3x as it is. So one of the products is e to the 3x. Now what happened here? It seems like you hold y as it is and differentiate e to the 3x, because if you differentiate e to the 3x, you have 3e to the 3x. So the other member of that product is y. So you found the derivative with respect to x of e to the 3x times y. Alright? Now remember, when you differentiate e to the 3x, you have e to the 3x, 3e to the 3x, using the differentiation by substitution. How would that happen? If you say y is equal to e to the 3x, and you're finding dy by dx, what you say here is that you let u be equal to 3x. So you have y is equal to e to the u. Now, here, dy by du is equal to e to the u. No change there. Now, du by dx is equal to 3. Now, dy by dx, when you are working out dy by dx, dy by dx is equal to dy by du times du by dx. And it's like the u's cancel, right? But anyway, dy by du is e to the u. The u by dx is 3. So this is 3e to the u, but u is 3x. So it's e to the 3x, alright? So just a reminder of what happened here. You differentiate e to the 3x to get 3. Alright? So just a reminder of differentiation by substitution, which we call the chain rule. Alright? That's what happened. So back to this now. We found that this came from differentiating a product rule, and that product is this. So this is equal to, and you have 15e to the 3x. Now you still have a d by dx of something. What do you do? The next step is to integrate. You integrate both sides. So the integral of d by dx of e to the 3x times y dx, you're integrating with respect to x, is equal to the integral of 15e to the 3x dx. Now, when you integrate the derivative with respect to x, and you're integrating with respect to x, the function you're integrating comes out undisturbed, e to the 3x y. It is left undisturbed. Comes out of that process without any change. So here, this is equal to, you're going to integrate 15e to the 3x dx. So this is 15 times, alright, when you integrate e to the 3x, the integral of e to the 3x dx, when you're integrating e to the 3x, you use integration by substitution. What you would get is e to the 3x divided by 3. And then now plus c, you add your constant of integration. Now that integral a while ago, what happened? So earlier we saw differentiate e to the 3x, you get 3 times e to the 3x. And when you integrate e to the 3x, you have 3 under e to the 3x. Let's see what happens. You integrate e to the 3x dx. You let u be equal to 3x. Then you're integrating e to the 3x. E to the u dx. Because u is 3x. You want integral of e to the u du. Now, u is 3x. Let's say you have the u by dx is equal to 3. You want dx. So dx is equal to du over 3. If you multiply both sides by dx and divide both sides by 3, you're treating du by dx as a fraction. So dx is du over 3. Now you have a du. So what you have is the integral of e to the u du over 3. So what you'd have then, this is equal to 1/3 integral of e to the u du. Alright? And when you integrate e to the u, with respect to u, you get du. So it's 1/3 e to the u, which is 1/3 e to the, what was u again? U was 3x. E to the 3x. Alright? Plus your constant of integration. So here, that's a review of the integration by substitution in order to explain what happened here. You integrate e to the 3x, you get e to the 3x divided by 3. Alright? So when you differentiated e to the 3x, you get 3 times e to the 3x. When you integrate e to the 3x, you get 3 divides e to the 3x. Alright? Okay. So, here now. You can divide both sides by e to the 3x and simplify what you have over here meanwhile. So you have y equals, well, this would be 15 over 3 e to the 3x over e to the 3x plus c over e to the 3x. Alright. E to the 3x would cancel e to the 3x. 3 into 3, 1, 3 into 15, 5. So y is equal to 5 plus c over e to the 3x. So that is what you have. That's the general solution. Now, suppose you are told that y of 0 is equal to 1. It's the same thing as saying x equals 0, y equals 1. Alright? In order to find the particular solution when this is so, you're going to find the value of c when you do this. So y is 1. 1 is equal to 5 plus c over, when 3 is 0, when x is 0, you have e to the 3 times 0, which is e to the 0. E to the 0 is 1. So what you get from this is that 1 is equal to 5 plus c. If you subtract 5 from both sides, then 1 minus 5 is equal to c. So c is equal to -4. So what you would get here is y is equal to 5 plus, well, could say minus 4 over e to the 3x as your answer. Right? So this here will be the answer when x equals 0 and y is equal to 1.